Oh man, that was so fun, guys. I just came off a video conference call with Chris, lead chemist and R&D development over at B&B Blending. So a major blender of car care products. So an independent chemist from a chemistry department that takes care of formulating car detailing products. And you guys are going to be a witness to that talk and conversation in this video. You absolutely want to stay tuned from beginning to end because we'll be talking about cool things. I know you guys enjoyed the previous discussion I had with a chemist from a leading car care company about graphene coatings, so debunking myths. Are graphene coatings just snake oil? And you guys absolutely love that. You also asked that I speak to an independent chemist, so not from a car care brand. So that's what we're doing today. Again, we're going to talk about the graphene coating technology. See, is that actually true? What's in the bottles? Why are they using graphene as marketing? Are all the companies as well, now that we have access to a blender, when company A and B both come for a shampoo, are they both the same formulation, just different scents and different dyes or colors? Or are they different? How does that process work? A bunch of other questions that I had and you guys had as well that we're going to answer. I think you're going to learn a lot, and we're digging really deep, and it's all thanks to you because we built one of the biggest car detailing channels on YouTube, and we have now access behind the scenes to these kinds of things. I think you're absolutely going to love this conversation. And yeah, so graphene coatings are the thing right now. Are they true? Are they not? Are they the future of surface protection? We're continuing discussions with that topic, and you're going to learn, of course, as usual, a bunch of stuff to allow you to make better purchasing decisions and to have more knowledge about the car care industry and the car detailing products that you're using. So you know the drill, guys. Without further ado, stay tuned. Let's go ahead and start the show. So hey guys, welcome to another interview with Pan the Organizer. So I have a very special guest here today. I have Chris from B&B Blending. So hi Chris, how are you?
Good, how are you?
Yeah, I'm doing great. Thanks for giving me this chance to interview you. Basically, Chris is the Chief Technical Officer at B&B Blending, basically a blender of chemicals in the car care industry. So I'm going to let Chris introduce himself to my audience. What are your credentials, and basically what is B&B Blending and what do you do for the company?
Yeah, hi. So I've been working with B&B for the last 7 years. I'm the technical head of the lab, and I have a lot to do in operations as well as sales, and involved in a lot of different organizations. But a company like B&B Blending, we're a private label distributorship. So a lot of people out there have probably heard of us and what we do and speculated on who we make for and things like that. But
yeah,
we're a total turnkey operation. So we do all of the development in-house. We have our lab. Manufacturing, packaging, labeling, shipping, graphic artistry, SDS, and regulatory compliance, like the whole deal. We service quite a few brands ranging everywhere from the OEM and body shops to professionals, car care enthusiasts, e-commerce brands, wagon jobbers going around the dealerships with the route trucks, basically all of it. We're involved in a lot of both domestic and international business. So we've kind of seen and done it all. Have a lot of talented people within the building that have been doing this for 40 plus years. So we come from quite a diverse variety of skill sets and backgrounds, and really powerful formulator because we have quite a variety of formulations to pull from, over 2,000 plus formulas, 500 plus raw materials. And so anytime we're working with a project, we have a really quick R&D cadence because we have such a breadth of knowledge to be pulling from. So at any given time, we could be as far as, 3/4 of the way done with a formula because we have something to start from and a really good base. So not everything's developed from complete scratch.
So my viewers understand your skill set because I see a lab coat behind you. Are you a chemist? What degrees do you have?
I went to Colorado School of Mines in Golden. I got a BS in chemistry from there. I actually did some time as a chemical engineer before I changed tracks. I eventually ended up specializing in biochemistry. It's kind of a requirement of mines that you have to pick an area of special interest. Yeah. And I also have a minor in economics and business, which has kind of led me to go into this business organization and management track here at B&B.
Okay. And so if I understand what you guys do, basically, for people to understand what blenders are. So let's say I'm company X.
Yep.
I need some type of shampoo or a wax or compound or a polish, whatever I need for my car care range of products. So I can go to you guys if I don't have a chemist or an or in-house lab, and basically ask you to custom tailor stuff for me and to basically create a range of products that I can sell and distribute.
Yeah. So you might have seen us at places like SEMA and things. So our kind of slogan is your brand, our technology. And so the idea is we don't have a brand. We don't market a B&B product out there. You won't be able to find it. So we're entirely white label and we go entirely through distribution. So there's no such thing as us ending up working with an end user. But we interact with companies that have a brand or an image that they're trying to create. And we basically are the ones supplying the juice that goes into the bottles.
Okay.
So we can manufacture everything from compounds and polishes, waxes and sealants, coatings, dressings, cleaners and greasers, powders, all kinds of different acids, cleaners.
Graphene coatings.
Mm-hmm.
We're going to get into that.
Yeah. And so we just have a variety of industries we serve. We don't even strictly work in just car care. We also do things in marine and automotive. We've worked with fire departments. We've worked with departments of transportation in various states doing kind of some specialized projects. And kind of our trick of the trade is that we borrow from a lot of other different industries. A lot of different things that are going on in like the cosmetics world, for instance, works really nicely in car care. So we're a pretty talented bunch and have a lot of variety of things we work on.
Just so my viewers have maybe a breadth or a scope of your operations, because to me, you're one of the most known blenders in the car care industry. When we're talking, without naming names, obviously, of companies, I understand that for legal reasons. However, you're probably not dealing with just 10 or 20 companies. Like, how many brands do you know how many brands you deal with?
Mm-hmm. I think the last count was, approaching 400. So
That's a lot. So you know what? I'm sure a lot of my viewers have the same question because I see this come up either in YouTube comments or on forums, on Facebook, or even on Instagram. So when we talk about a blender, so company X, company Y, company Z, they come up to you, they ask for a shampoo, they ask for a wax. Many people think that they're all the exact same thing, the exact same formulation, and the only thing that changes is the color and the scent maybe. So is there any truth to that? Is it true that all the companies can only access to a single product from each category? Like there's only one wax and you only get the change and pick the color and the scent, and that's it. You just slap your label on it and call it a day. What's your take on that?
Boy, I really wish that was the case. That'd make our world a lot easier. In fact, it's quite the opposite. The reason why we have these 2,000 plus formulations is because we also have thousands upon thousands of those that are variations on those. So when I say 2,000 base formulas, that's literally 2,000 individualistic formulations. But then when we're dealing with a new customer, it's very frequently that they don't come in and they're just going to want, house formula A with blue color and blueberry scent, for instance. They usually come in with specifications. They have something that they're trying to market. So they work with us in the lab to understand what is the capability of the chemistry? What are we capable of creating? Oftentimes they're challenging us to make things that we've never made before. Maybe it's smashing two formulas of ours together. Maybe it's a new take or a spin on something. But kind of the challenge to us and our team is making each of those customers very differentiated. So we wouldn't get very far if everyone was selling the same shampoo. So someone might want the shampoo to be thin, someone be thick, someone to have it be extra foaming, someone to have protection and polymers in it, someone to have some other sort of claim they might be able to make. So I think the people that are the most successful are the ones that come in and they do work with the lab and they do have a specification or an understanding of something they want to create or an image that they're trying to be. But realistically, all the brands we work with, I think, add a very unique flavor to the industry, and I wouldn't call anyone exactly the same. Some of them, it's all about the product and they want the best performance possible. And they're constantly challenging us to innovate and make something better. Other people are more interested in the educational piece and teaching people how to detail, and the chemistries are just the tools of the trade. And then other people are on completely different cadences. They're different points in time on their organization, and different entrepreneurs are at different points in their career. So certain things aren't appropriate to everyone. So yes, there are people that come in and they take the house formula, or they take the house formula with a different color and scent. But those aren't going to be the ones that most viewers, are going to be able to recognize.
Okay, so you're saying that it can happen that two companies might have same formulation, but that's because they didn't want to give their own specifications. Because if they do, you guys tweak the formulas to whatever needs and wants they have for a particular given product.
Yep. And it just depends on what their end goal is. I mean, so the way we work with our formulations is we design and develop them in order to have specific knobs we can turn. So I've been known to describe it as a big tune and a small tune. So we have things that we can turn that we know will accentuate certain characteristics of the product. And then sometimes it's a full blown like redo, and it's like nothing we have is really going to cut it for what someone's looking for. And that's when we're innovating and developing something new. And so we have a very aggressive R&D cadence with a lot of projects in our workflow. Some of them I describe as new product development. So these are ideas that have came out of the technical team, and it's a technical push. And then we have commercial projects that are commercial pulls, where we have demands of us from our clientele or from the market. And so it's kind of a dynamic tension between the two, that we're developing new products based on conversations we're having as the formulators with chemical manufacturers that are developing unique and novel raw materials. And we'll get into more of that later. And what the commercial team is saying that they need are answers to competitors of ours, something that they develop, and our commercial team might say, hey, we need to pivot and answer something like this, or can we answer this but with a twist? So kind of what I'm proud of my team capable of being able to generate is building unique aspects onto formulas. It's not our interest to rip someone off or to develop a clone of a formulation. We always try and do some sort of a unique spin on something, or an evolution on something, even when we're being asked to just give someone something that's very plain. A lot of times we don't make anyone's formulas for them, really. So anyone that usually tends to come to us, maybe they're getting their stuff blended somewhere else, or they have a proprietary formula themselves. They'll often provide us formulas, and usually in the process of working with the customer to tweak the formulation, make it the way that they think that they want it, and sampling it, it tends to evolve, and it tends to gain kind of a life of its own, and we end up making something different and better. And that just, ends up kind of evolving that IP.
Man, I got so many questions. I love geeking out. I'm so blessed to have an honor to be able to talk to people like you in the industry, and to have my viewers benefit from this. So now there's more questions. So it seems that you have a capacity, or this ability, to have so much R&D. I see it as you have an outlook into the future of the car care world, and you guys are basically shaping what's going on. So am I correct in saying that you seem to have not necessarily an influence, but you envision things for the future? You come up with these creative ideas, and then we'll come up with probably stuff like the graphene coating, which we'll talk in a few seconds. But so you have this vision of what's to come, or you create. How does the thought process go for a blender? Like, how do you guys say, you know what, we're going to move on from ceramic coatings now and look into something new?
So again, like you said, a lot of this stuff, we're working with manufacturing and suppliers that are creating new and novel ingredients. And there's a very collaborative approach to that, right? So they're not just making stuff and then sending it out saying, is this interesting? Is that novel? There's usually a back and forth of, we're looking for something that we either have a technical idea on, that technological push, or we have a commercial demand for it. And it's a very collaborative thing between manufacturer and developer, just like there is manufacturer and brand and consumer. It's all working together, where someone's making a unique raw material, we're developing stuff with it, selling it to brands that are then developing the marketing and showing it to consumers, and building processes and procedures around how to use it, so that an end user gets a practical benefit. So with someone like us, where we control so many brands, we are the lab, the technical house of all 400 of these brands. None of these brands that we interact with have their own lab and their own chemists that they're working with us on. It's like we're the brains kind of each of these brands. And so there's a very large, I would say, moral responsibility of us to basically understand what the market is tending towards. And like you said, we have a bit of a strong hand in the narrative of how the car care industry is shaped. So we've been, I guess, either lovingly or, attacked, saying that we're the invisible hand of the industry, and it's not entirely inaccurate. If as the technical director, I can say, I want people to be talking about graphenes now. We can develop a novel coating, and you're going to see 400 plus brands as points of light entering the industry talking about graphenes. So in a lot of essence, people like myself and, people like David, like you previously talked to, are who's responsible for why you're seeing products on shelves and in stores, is because we're the ones that are basically bringing those things to life and telling these brands that's what they need to be working towards, and that's where the market's going. And we're thereby doing that from education from these suppliers. They're telling us what they're capable of creating, and then we know how we can create something from that. Okay. I know that's kind of probably getting a little convoluted, but essentially, we are a lot of what the narrative of the industry is going to be.
And you kind of spoke about, well, it comes up with the different brands you partner with. I think another probably myth or questions that people often have is that there are many brands out there that have their own chemistry departments. They have their own chemists, and kudos to them because they can innovate and create stuff in-house, which is awesome. Yep. But there's this myth kind of, the companies who reach out to blenders, well, that's not as good. Again, they all use the same products. You talked about that, so that's not the case. What's your take on people believing that companies that have access to blenders somehow are lesser companies, or they can't possibly be as good? So although that, because the way I see it is, I don't really mind if a company does their own products or they reach out. It's totally normal to reach out because, again, not everybody has the funds, budget, or R&D or chemists to do the work. For me, it's what does the end product look like? Does it satisfy your needs? Does it perform well? Look at the actual real world performance you're getting out of a product. Don't only look for brands that create their own products, because it can be good, but it can be bad as well. Because if they don't have enough budget, or the chemist might not be the best in the world either, well, That doesn't mean you're getting a better product. But what's your take on brands that are considered not as good as others if they don't produce their own products and they reach out to blenders like you guys?
I mean, perhaps I'm a little bit biased, but I think there's a lot to be said about specialization, right? So companies that do develop everything in-house and have all their verticals in-house, they manufacture their own product, they package it, they label it, they work with retailers to get into stores or .com. There's definitely, like you said, a lot of respect that goes into that. But there's also then a splitting of your interest and the splitting of your attention. Maybe the company at the time is working on a big initiative to push into brick and mortar stores or something. And so innovation might go on the back burner for a little bit because they're tied up with something else. Having a situation of where a company can come to us and let us do all the turnkey stuff that's unsexy, like the manufacturing, the development, and doing all the SDS compliance and the graphic artistry, while they focus on building a marketing campaign and a way to get consumers excited to use the product. I think by having both people specialized in what they do, it actually creates a bit of a lightning rod of activity, and things actually go from an idea in the lab to develop to the market a lot more quickly and a lot more thoroughly, I would say.
So basically they still have access. It's like if the product was their own, because they have their own criteria. Yep. So they give you those criteria. You guys come up with a custom solution for them. And in the meanwhile, on their side, they can focus on the marketing, the sales. And so you'd say the approach is for a company to be able to be more focused on some tasks instead of having to worry to do all the production side and the innovation basically of the chemistry, right?
Yeah, it's part of the services we offer. So, you're not worried about, with COVID going on, you're not worried about your supply chain of your raw materials and your bottles and things like that. That's things that we're supposed to be solving for you and allowing you to focus on growing your business.
Absolutely. Okay. Well, now I think it's time to talk about what we're all here for. Graphene. Uh, there's been a lot of talks and discussion online. I feel like we're back 5 or 6 years ago when ceramic coatings started to be super popular. There was this entire drama around it. You cannot bottle silica. What is this? Is this a glass coating? You can't put glass in the bottle. What is SiO2? How much percentage is in there? People were freaking out on MSDS sheets. And fast forward 5, 6 years later, we all know how fantastic ceramic coatings can be. And of course, they've progressed and they've become better and better. But it was a true technology. And I kind of see the same thing happening now with graphene. Popularity, of course, everybody's talking about it. Many brands have already dipped into the graphene world about a year ago. I think it started for many of them.
Sure.
And they're getting better as time progresses. And I'm sure the future will get even better. But first of all, what is graphene? What's your take on that? And everybody says you can't put pure graphene in a product. So it seems to be more a graphene oxide, so a derivative. Are there disadvantages of having that in formulations? Are we getting to a point where pure graphene is going to be there? Is that needed? So basically, first of all, what is graphene and why did you guys start developing it for the car care industry in particular? Why go from something that was working super well like ceramic coatings, other than maybe a bit of water spotting issues on traditional ceramic coatings, but that was alleviated with a bit of toppers that you apply on top. However, that multiplies the steps that you need to correct the issue. But basically, what was the thought behind it? So let's start with what is graphene and why you guys thought of this as a great partnership for the car care industry and the evolution of surface protection.
Sure. Lot to unpack there, but
yeah,
essentially, David went through graphene and graphene oxide at a pretty technical level yesterday. So I'm going to try and speak to it more of a layman type terms.
Just so my viewers understand, when you say David, that was David Gutierrez. He's the lead chemist and R&D of 303 Products. So that was another video that you guys can watch on my channel. We were basically asking if graphene coatings were snake oil. Yep. So yeah, continue on.
Sorry about that.
Yeah, no problem.
Essentially, so graphene comes with a lot of baggage, right? Because people are already fairly familiar with it. It's something where ceramic coatings kind of took the industry by storm and a little bit by surprise, even though it was a lot more popular probably in other parts of the world before it hit the US. But there's been a huge misconception, a lot of misunderstanding of what graphene is, what graphene oxide is, and, understanding that graphene as a specific, multiple layers of graphite has some unique properties and some physical characteristics. Graphene oxide is a derivative of that, right? And so as David was highlighting in his video, you need those oxide groups on the surface of the graphene to do work. One good kind of analogy I'll throw out here right here at the beginning is Lego blocks. You can think of graphene and graphene oxide as Lego blocks. The graphene oxide is the one with the nibs on it, and graphene would be one that doesn't have any nibs. So they don't really connect and they don't really do anything with other chemistries, but with the graphene oxide on there, you can then bolt other things onto it. So whether that be building it in with ceramics, as I'm going to get into in a minute, or having it interact with surfactants and having it be capable of emulsification into water-based systems, which is really novel. The difficulties with stuff like that is how you source and how you react to get to your graphene or to your graphene oxide. So some of the kind of holdup to getting to this point has been on the material science and on the manufacturing side, upstream of people like David and I that are formulators. So as he highlighted, same with us, we don't have these big reactors in our facility. We're not doing these crazy complex reactions to develop these things. But what we are doing is working with those manufacturers and bringing some unique molecules and some unique polymers and chemistries into our formulations. So in the case of like a product that we've developed, and again, not naming brands, not naming formulations, what we've been working on is developing a ceramic coating plus. So basically our previous quartz coatings were best understood to be basically a polysiloxane, right? And that could be a perhydropolysiloxane, which means it's all hydrogenated. It could be something like an organopolysiloxane, which usually will have some methyl functionalities on it. So those are CH3s. Those essentially act as contaminants. They don't allow cross linkages and stuff to occur. You can fire the coating film to try and drive those things off in the form of methane and try and get additional cross linking and curing. But for the sake of applying to a vehicle, these are what we would refer to as like ambient temperature curable refractory resins. You're using solvents to cut them so that you can deliver them to a vehicle. The solvents flash off. Oxygen's donated via water in the humidity in the air to catalyze the reaction, gives off ammonia, and makes a curable film that actually kind of shrinks and cures into a glass-like state, right?
Yep.
So where the idea for something like a graphene came from is we're then talking to these manufacturers saying, what if we intentionally got rid of these methyl groups and built on something that we wanted instead? Something that added functionality to the coating, something that added some ability for the coating to have additional scratch resistance, additional chemical durability, and additional other properties. And that's essentially what happens is they go, okay, they're going to do their mad scientist thing and develop these in very expensive reactors, tens of millions of dollars invested into these reactions, very dangerous, really harmful byproducts. And they're developing us these resins that we then use as building blocks in our formulas. So the best way to describe what we've created with our graphene coatings is you can think of the graphene oxide in these situations as a brick. And then you can think of the ceramic resins as the mortar that holds it all together. So the mortar is acting to keep the brick bolted to the surface, as well as orient and build out the graphene oxides to kind of stabilize themselves and build that up.
Very interesting analogy.
Mm-hmm.
So you would say in your case, the formulas that you're coming up with is a ceramic kind of backbone, and you're adding graphene oxide into there to boost certain properties?
Yeah, so one obvious affiliation I have, and I'll just say it is we're associated with Adams Polishes, right? And they've launched their own line of graphene ceramic coatings, and people, of course, came out and said, "Why would you call it a graphene ceramic coating?" And the reality is it was an attempt on my part with our marketing team to present it as technically accurate as we possibly could. If we want to get incredibly technical, it's a reduced graphene oxide ceramic coating is what we've developed. But that's a mouthful. That's not a good thing for search results and stuff like that. So there's a marketing component to it. But understanding that we call it a graphene ceramic coating is simply because it's everything that a graphene coating would be and everything that a ceramic coating would be, but at the same time. It's a hybridized system. The graphene won't do anything by itself. The ceramic is already current technologies. And so what we're doing is we're building up the ceramic coating with additional intentional functionalities that we wanted to use to increase its throughput and its performance. So it's a very intentional thing.
So for people who think it's just a marketing ploy, no, it was actually intentional. And so you guys know that you are, and you're basically, you just said it now. So many companies are using ceramic coatings as a backbone, and then you're adding graphene oxide into there because it blends well together because of the oxide groups.
Yep.
And so that adds functionality to the product itself. So I guess maybe a lot of the frustration from the viewers from my understanding is that people seem to be focused on why are they calling it a graphene coating? Why is graphene in there if it's graphene oxide? So I guess because if you were to say the whole entire thing, well, it is a mouthful, and I guess it's purposely done from a marketing perspective to keep things simple to use the word graphene. So because people say, oh, it's misleading. If you people call it's a graphene coating or a graphene based coating, automatically it's misleading and it has to be snake oil.
I mean, so the reality is it's as technically accurate as you're going to get with something like a graphene coating. It's technically fair to say that. It's technically fair to say it's a ceramic coating with graphene. It's technically fair to say it's a graphene coating or just a ceramic coating. All of that is true. But the part that I bring to this picture as the technical officer is that there's a marketing component to all this. So at risk of getting attacked in the comments here, we have to do these things because of how consumers behave. We literally can't give consumers what they claim that they want, which is all this transparency. I'm like, would you go Google a reduced graphene oxide ceramic coating, or would you drop
unless you're a chemist?
No. Like, that's not going to happen. And we have to understand how our competitors are going to behave as well. If we don't nab up keywords, they're going to nab up keywords, and no one's going to fight fair. And so there's literally a marketing component to this, and there's a consumer behavior kind of component to it. And we try to drive as much as we can from a technical standpoint of like being as accurate and faithful to it as possible. We're seriously genuine about the chemistry that we're creating. But at the end of the day, it's a competitive atmosphere. there's a marketing piece to it. There's search engine optimization and all this other stuff that goes into it. And
Keywords,
marketing's a necessary evil. We have to market a product or you'll never hear about it. And anything that myself and my team create, you'll never be the wiser because you'll never have seen it.
Yeah.
So it's just a necessary evil, to be honest.
And I'm sure the same applies to anything else. If you were to use the technical terms, let's say for even just a standard synthetic paint sealant, if you were to call it by its full chemical name, then nobody would buy it because they're like, okay, am I buying chemical powder? What is this? It's not, well, and then they understand paint sealant. Okay, it's going to seal my paint, or a carnauba wax, although there's a lot more stuff in it than the average person can think of. Well, so thanks for being transparent and honest about that. I think my viewers will appreciate that. So nobody's getting ripped off by it's just a name and there's no actual graphene oxide or graphene based product in the bottles, right? So it's not just a liquid that you guys are going to add a bit of powder inside, whether it's graphene or graphene oxide, and it has no actual positive impact. And it's just to market it as, here we go. It's basically an SiO2 spray sealant or an SiO2 ceramic coating. We sprinkled a bit of that magic powder in there just to call it a day and to make money. So that's not what it is.
No. So like to go another degree of transparency deeper, when we were developing a coating like this, we have the capabilities of making it a strictly graphene oxide modified polysiloxane, right? But it would look just like the quartz coatings. It would be clear and colorless or a slight yellowing tinge to it. And everyone would call bullshit on that one too. They would say, that's not graphene. Graphene's black, it's carbon fiber, it's yada, yada. So what we've actually had to do, and this was part of working with the manufacturers, is I'm telling them, purposely give us partially reduced graphene oxide so that you pull some of those oxide groups off and you end up with literal graphene or very lightly oxidized graphene. And that's the black stuff floating around the blend that settles out. It really doesn't have a whole lot of effect.
Okay.
The graphene oxide and the actual modified resins are in solution, so you can't see them. So it's essentially like, is it easier for us to market to you that this is a graphene coating without black in it or with black in it? And part of the marketing and the R&D team collaborating was we need to have the black in it. We need
so the black portion isn't really necessary is what you're saying. It's more so people understand that there's a difference with a graphene-based coating compared to a non, so it's that black effect. Yep. However, you're still getting actual graphene oxide, which is the functional component, and you're getting the benefits from it too.
Yes, and you're getting
so there's both.
You're getting the part that graphene would contribute to performance. The oxides are the connecting points. They're not going to change the behavior of how it works. You're still going to get everything that graphene provides you. And we'll talk about that in a minute about water spot behavior and things, because I had a little bit of a disagreement with all this thermodynamic stuff talking about it. But we wanted these products to be familiar to people. We wanted them to be graphene ceramic coating. Okay, so it's like my process isn't going to terribly change. And we wanted there to be an obvious difference there with the black. And that was all intentional. And it's trying to appeal to people's behavior and making people think it's different but familiar at the same time. Like there's psychology to it. But the reality is from a technical level, and we'll get into this too, is there's definitely a performance increase and a technical benefit to what we're doing. It's just hard to convey that on just bullet points on a web page, for instance. People won't buy it. They'll be like, bullshit, it looks like it's a quartz coating. So
that's why I like doing these kinds of videos, because I like to educate my viewers. I think it's not only detailing is amazing, it's soothing, it can be entertaining as well, but a part of my channel is to educate. And I feel by empowering people with more knowledge and information, it allows them to make smarter purchase decisions because they can make their own mind up with correct and proper data and info. And then when they test them themselves, they can make their own mind and see if it works for them or not. But at least if you have a backbone of information, I mean, this is great. This is golden stuff that we're talking about today.
And understand, part of why I'm comfortable talking about this is because this is a very difficult technology and not many people are going to be able to pull it off. To me, there was definitely a case where with ceramic, you had the effect of having silicate resins or SiO2 resins that people could market as well as ceramics, and they're not the same. This is where we're truly getting into the same resins that go into the top coat bottles are going into water-based products and into other products now. So you're truly getting ceramic resins into these products, and that's due to the graphene oxide. It's not possible with the previous chemical technology of the siloxanes and things. And so This is going to be a case of where a lot of brands aren't going to have this. They're not going to be able to develop this, and there are going to be people that are behind and people that are taken by surprise. And I think that's part of why so much drama here at the beginning is, how are these e-commerce brands the first to the market with something that's so novel? So it immediately kind of turns the formula on its head of like, well, if this is so novel and interesting and powerful, why don't the professional brands, I'm going to put that in quotes, have this already?
You hit the nail on the head, because that was a question of my viewers. So a lot of mainstream brands, let's put it that way, came out with their graphene coating offerings. But why aren't any of the professional grade, whether it's CarPro, Geon, all those bigger brands, not to name any names, but why aren't the ones used by professionals, why don't they have graphene? So that must mean that graphene is impossible and it can be implemented, and it's complete snake oil. Is there any truth to that? Because I'm pretty sure a lot of the pro grade companies still use blenders that are accessible to them. And I mean, you guys are the same blenders, whether it's for pro grade or mainstream or so. What's your take on all of that?
I just think the market's shifting. I think a lot of these brands and a lot of these technologies are getting more and more easier to use. So it's making more and more sense for the e-commerce brands and the more consumer focused brands to immediately get it to market. And I would say those brands are also getting more highly aggressive of getting involved in their R&D and bringing it to market. They don't need the professional market to validate it before they bring it to market. The chemistry is just getting that good where you don't, like traditionally we would market something to our professionals before our consumer focused brands, simply because it's a little bit more technical to apply and it's a lot more complicated and you can get into trouble. That's not the case with these coatings. They're getting almost disturbingly easy to apply for how much ability you get. And so it's just kind of a fundamental shift in the market where we're kind of like developing this and we're like first to market wins. And we're not, you know, I guess in some senses, we're not protecting the professionals like we used to. And it's just because the market is going more and more towards those consumer focused brands. If I'm being honest, that's where a lot of the volume's at. And so the reality is the blenders that are creating a lot of the consumer products are also making the professional products, people like myself and my team. And there's not a ton of formulators out there. There's probably a small enough group that we could fit them in a room. And so there's going to be things that my team is more aware of than another team, and things that we're getting the jump on other chemists on, and there'll be things that they're getting the jump on us on. And it's just a case of like information wins and knowledge is power. And as a big blending house like B&B is, we've aligned ourselves with some pretty powerful manufacturing and suppliers and vendors of these unique raw materials. And then we're pairing that with the expertise that we have in-house of our powerful formulary team to bring those to market quickly and really powerfully.
So
let
me ask you a tough question.
Sure.
Because I have a bunch of them. I'm well prepared from my audience. So one thing they noticed is there were a few videos out there, some that present the technology in a good way, others that seem to say there's some chemists that were saying, well, it's not a technology that we've seen that brings any advantages. It's not a technology that's possible. So they discard that technology as being possible. So what some viewers started noticing is that it seems that some chemists from brands that maybe haven't cracked the graphene code yet or don't have access to it discredit that technology as being impossible and snake oil just because they can't do it or they don't see the benefits. And then others obviously give us the benefits and tell us. So as a blender and somebody that's not an actual brand out there, what is your take on, are there true advantages of using graphene coating or graphene oxide based coatings out there? Is it just snake oil? Obviously, we've been discussing this for a few minutes now and it's not. So what is your take on the ones who say that, nope, this technology is impossible and we've seen no advantages in our testing?
On the videos I've seen, I think it's because there's a fundamental misunderstanding that came right out of the gate as these products started showing up, that these were liquefied graphene or molten graphene into a liquid solution. And so when you go to a chemist and you ask the question the incorrect way, we're going to give you an incorrect answer, right? So if you go to them and you say, is it possible to have technologies containing graphene? I would certainly hope certain chemists would be aware that there's things like graphene oxides, which are much more readily formulatable, right? They're much more flexible to formulary work. But if you go to them and you say, is it possible to have a pure graphene coating? They're of course going to give you a literal answer and say, no, the technology is not there to make a molten carbon nanotube coating to apply to your car and give you all the suppositions of why it'd be too expensive, you wouldn't be able to source it, and all those other things.
Yeah.
So I think it's almost the way that the market framed the questions to some of these professionals. They're kind of looking at them going like, that's a ridiculous question. That's not possible.
Because you asked something that's so specific, well, they're going to give you the true answer to that specific question.
Chemists are very literal people, and we're all very technical and right-brained and everything like that. So we're going to give you the really down to detail answer. So it's like, you got to be almost careful how you frame the question. But when I've been seeing people asking the question and then getting their answers, I'm like, you're not asking the right question, and you're kind of almost pushing the chemist into a corner where they have no choice but to tell you it's not possible. Additionally to that, even as someone like myself, if someone comes to me and says, hey, there's a spray detail that takes out defects, leaves a ceramic coating on the surface, and your car also, transforms into the Batmobile. And they're like, is that possible? And I'm like, I don't know how to do it, so I'm about to start discrediting how it's possible.
Yeah.
Right. And so it's a lot with them too. It's like if a CEO is going to come to me and say, some other company's beating us to the punch on a new technology, we're going to present to the market, it's not a thing, don't go buy that. And then we're going to go back into the lab and scurry to try and figure it out as fast as possible. And I wouldn't be shocked if that's kind of the case that's going on right now, is there's probably a lot of brands that are scrambling a bit.
Because for me, having that science background as well in biochemistry and molecular biology, I always applaud people who bring forward new technology, who are forward thinkers, and who continue innovation. If there wasn't innovation, we'd still be stuck with paste waxes from the 1950s with no paint sealants, no ceramic coatings, no silica spray sealants, and certainly not any graphene oxide or graphene based coatings out there. So I think to discredit a technology just because a question was not asked properly, or you haven't maybe cracked the code yet, or you haven't innovated into that sense yet, or understand maybe even the technology, I find we have to take that with a grain of salt. And that's why I think these videos are so important, to kind of understand the technology behind it, what's possible right now, what is the future, and to educate people that, no, this is not snake oil. This is actually a true existing thing. Which leads me to my next question, because we spoke about the marketing choices before. Instead of saying graphene oxide based this and that and the whole technical aspect. So graphene coating is easier to understand. But if we look at it more technically, as far as the chemistry goes, so pure graphene is essentially a 2D layer of 1 atom thick carbon atoms.
Yep.
So that is supposed to be stronger than Kevlar, stronger than steel. And so I can see how people wanted that to be available now, but it's obviously very costly, hard to source, and obviously hard to implement. So why the shift to graphene oxide right now? And do you think there's a future possibility to have pure graphene integrated? Like, is the technology going to go forward enough to be able to integrate? And do we want that? Essentially, would people actually need or want pure graphene? Or is graphene oxide actually what we need in the car care industry?
I think it's a lot like, silica and SiO2, right? Like, we're not putting direct silica onto a vehicle, it's SiO2. It's a lot the same with graphene, where it's like RGO and GO, right?
Yeah.
Part of why we're developing this technology is because it's the next logical step. So anyone that's kind of versed in their chemistry is going to know this is sort of where to go next. There's another few avenues and things like that you can take, but this one was the next logical approach. And so those are the conversations we're having behind the scenes with formulator and manufacturer, saying, this is what we want you. We're doing a commercial poll on those same manufacturers saying, this is what we want you to develop because it's theoretically possible. And that's just the natural progression of things. There's obviously already a ton of research papers and things on the benefits of graphene oxide going into composite materials to give them more scratch resistance and more chemical resistance, and a lot of the same characteristics that we want to bring to a car surface to protect it. So naturally, as a technical head, I'm challenged to bring those things to life and bring those attributes to bear in our formulations. And so, that's just kind of the natural progression of things. And I do think with the ability for the graphene oxide ceramics to be pulled into water-based solutions, it's a whole nother renaissance of kind of car care that's going to be happening. You're going to be having all kinds of different insane polymers that never should have been able to get onto a vehicle, and traditional detail sprays and soaps all start flooding the market. And I think it's going to happen a lot sooner than we think.
So you think there's a future for actual pure graphene in car
Not
care products? Or
necessarily. Just like how
okay,
I don't know that there's a future for a pure silica coating or something like that. It's
okay,
in chemistry, like pure materials don't always tend to be the best. It's about, you know, combining elements and molecules and things like that. There's no formulas we make that are two ingredients, right? They're all blends, and that's
yes.
why. So it's the same thing on an atomic level. Is you need blends of atoms. They all have different valence electron shells, and they all have different ways they share electrons, and all kinds of different surfactants have different reactions with things, and it's very complicated for a reason, and it's because these are all blends.
So to make it easy to understand, maybe for the average Joe and the weekend warrior, or for the end consumer, should they view graphene more as a general theme of like, don't worry too much. Is it pure graphene? Is it graphene oxide or no? There's graphene components in there in a blend with a base of ceramic, or even if you don't think about the base, just basically a blend of a product that is graphene based that will give you benefits, and that is an evolution in surface protection. So just see it as a general theme of here is a novel take or an evolution on stuff that was already existing, and it just so happens that it's graphene based technology. Is that a good way to see it?
Yeah, I can't word it any better than that. That's exactly right. Is you the Joe Blow consumer get to have all these benefits of all these nanomaterials now being able to be built into practically every facet of car care and detailing. All the over the hood chemicals all have capabilities of applications with this technology once we get into the water-based arena. So
And that's what I wish people would know. Like, we're in the 21st century, guys, and this is nanotechnology that we're getting into the everyday car care products. This is not like in a diamond cutting facility in the bleeding edge tech at Facebook or at Google, or with I don't know, infrared sensors and laser beams. And no, this is stuff that you're actually putting onto your vehicle. So I think we should applaud the industry for forward thinking and pushing the limits of what is possible for surface protection. And I mean, out of a spray product now, you can get up to a year of protection. Like, are you kidding me? How can you not be happy? Here we were like just a few years ago with traditional carnauba based paste waxes that would take forever to apply, for like impossible to buff off, leave white residue all over the place. And you'd maybe get 1 to 2 months of real world protection, especially if you're in harsh environments. And here we are now with a spray that you can go around your vehicle with in 10 minutes, can give you up to a year of protection, chemical resistance, hydrophobic properties, UV protection, slickness, gloss. I mean, what more do people want? So it's funny that there's been such drama around technology that if you're actually using it, so try it and see the benefits. And it's impossible that you don't notice the improvement on your paintwork. All of that in a spray form, or even the ceramic coatings based with graphene that you'll apply more like traditional ceramic coatings. I mean, the technology behind that, and you're getting 3, 4, 5, 7 years of protection. Like, what more are you asking for? I'm blown away. I don't understand how not 100% of people are just blown back by all this.
Yeah, exactly. And it's like the consumer, unfortunately, probably going to get attacked by the comments, but the consumer is so basically entitled that they want all of that for $7.99 at Target in a 23-ounce bottle. I'm like, it's insane. I'm like, when I first started working here, the best things that they had in terms of technology were things like amino-functional silicones. And we still at that time were like, this product is insane. You can get up to 30 days of protection. It's nuts. And I'm like, now we're making these 5-minute spray detailers that will keep your car crazy nice for a year. And people are kind of like, yeah, but this other guy gives me 18 months. And it's like, that's insane.
It is. Yeah. No, and I think it's important to convey to people just how amazing the push in technology has been. And there's things for everybody now, whether you want a $20 product that performs well, or you're willing to shell out $150 for a more traditional style of a coating. I mean, there's stuff for everyone out there, and you're getting tremendous performance for your buck. Even in the lower end of the scale, you're still getting tremendous performance. So I think that's a huge thing. But if we jump into the actual benefits of graphene-based coatings.
Sure.
So one of the things that has been touted the most, other than, of course, they give you the gloss, the slickness, the UV protection, the chemical resistance, the durability, obviously. But one main thing that I noticed was the water spotting. So they all say that you have reduced, not that it eliminates fully water spotting, but again, people have to put this in their brains. It's not that you're removing the problem entirely. What it's doing, it's reducing the chances of getting water spotting. And from my testing, because I don't have any issues with my personal cars, because I do have a water softener system at home. My water was already super soft to start off with. So it's not an area with hard water issues. And my cars are garage kept. So I don't have issues with water spotting. However, the daily drivers that I apply products to, I'm lucky because I get to see them often come back for more services. And so when I apply the graphene coatings that I've been testing, what I did notice by splitting the could half with a ceramic and a graphene based coating is that there was a reduction in water spotting. And also maybe another cool thing is that they were easier to wash off during just a maintenance wash. So instead of having to resort to machine polishing to remove them, or acid based cleaners, or vinegar and water, or what you not, I found they were a lot easier to wash. So I do see that there's initial benefits. But can you talk about the water spotting issue diminishment, and also some have been using tests with heat guns? Is that a proper way to test? Because it's supposed to lower the surface temperature by dissipating heat a lot better. Some call that BS because thermodynamics hasn't been explained well or not. Or so what is it? Does it actually reduce water spotting? Does it really reduce surface temperature? What is it from a science background?
So obviously I'll be speaking from the standpoint of our own formulations, and I can't speak for others, but essentially it's a matter of if there's reactive sites available still on the coating once it's cured. So those will frequently come in the form of hydrides, right? So in the case of quartz-based coatings, there's a high density of those hydrides across the surface. So every time water comes in contact with it, it can almost try and stick to that surface. And if it does get to reside on that surface, you'll actually get a little bit of the coating curing up into the water drop. And I've referred to that to some customers as like a silica water drop or a ceramic water spot. In the case of the graphene, you've now reduced that density of those hydrides considerably. So the reality is you could still get the same type of water spot, but it's much, much less chance for it occurring because the density is much less. So think of it back to our analogy of looking down on a brick wall, right? Yep. If you previously were just looking at it and it was just mortar, all of that mortar could potentially react. Now that you have bricks in there, think of it as the bricks won't react, but the mortar will. And so now you have much less surface area of your vehicle is capable of interacting with water spotting to have that occur. And that's literally why that happens is there's those available sites. And now that it's only partially polysiloxane and it's mostly graphene oxide, you now have something that doesn't react with those sites.
There you go. So basically what I was seeing with my own eyes, there's a scientific explanation behind it. So that's the reason why. So when we say there are less chances is because there are less sites available for water to react with, evaporate, leave mineral deposits behind. So you have less of a chance of that happening. So is there such a thing as lowering the surface temperature as well? Or in the products that you formulate, is that not even a factor? That has nothing to do with the water spotting?
We did some brief measurings like that and we threw it out almost immediately because, again, individuals need to understand you're not applying this on a macro scale. These are nanomolecular surface modifications. The coating film is far too thin, in my professional opinion, to offer you any sort of thermodynamic benefit. So people, like David was saying, people have been shooting it with IR guns and making their claims. That's realistically not doing anything. If anything, maybe you're measuring just exactly the surface, the top surface of it. But the reality is the coating is so thin and such a veneer, it's not going to have any sort of real framework to be conducting any thermal heat transfer through, right? So there is definitely a case to be made about graphene oxide and graphene as heat transfer coefficient efficient molecules, right? So, but you're going to have to do that on a much more macular scale to do that. You're not going to be able to do that on something that's literally molecularly bonding to the surface and it's only a couple atom layers thick. So to me, the thermodynamic piece isn't incorrect. It's just not applicable in this situation.
Okay. And so for people who like to geek out, because a lot of my viewers love the chemistry side as well, but in simple to understand terms, so on ceramic coatings that were technically more prone to getting water spotting issues, if we look at a water molecule, H2O, so 2 hydrogen and 1 oxygen, what happens on a ceramic coating as far as molecular structure goes for them to be more prone to water spotting. So what happens for that water to stick on the surface, want to stay there, evaporate, and leave those mineral deposits behind?
It's really not so much to do with the water as it is to do what's dissolved in the water. So, if you've got calcium and magnesium and these other salts in there, that's how you get things like hard water. So it's not necessarily the water itself, it's what's solubilized in the water that's going to cause those. And those calcium and magnesiums are ions, and they have the ability to react with a reactive hydride group on the coating. So then basically they'll bond, and the more thoroughly they bond, the more difficult they are to remove.
There you go. So you have a lot less of those hydride groups on graphene-based coatings.
Yep.
So there's an actual benefit.
The density is much lower.
There you go. Okay. So man, that was a crazy explanation. Hopefully everybody understood that. That's tremendous. That's why we're here. That's why we have these discussions. So are there other than that reduced amount of water spotting with graphene coatings, which I think is very welcomed? Are there any other benefits that you see right now in the formulations that you guys come up with to why you shift towards graphene coatings? Because I do see it as being the future of surface protection. I think it's going to be here to stay and continue to evolve. What more would you say that it brings to the table?
So what we're testing for in the lab is we take a qualitative and a quantitative approach to our research and development, right? So there's a qualitative piece, which is the real world stuff, the stuff that you see people like yourself doing torture tests and things like that, and real world analysis of putting this on a hood and driving it around in different climates and locales. There's a quantitative piece to it that especially my company focuses on, which is using analytical instrumentation to do all of the accelerated wearing, right? So we get a lot of requests of how do you get to 7 years, yada, yada. What we're doing is we're using instruments in the lab that are capable of measuring coefficient of friction. We're using optical tensiometers to measure things like contact angle, QUV weathering apparatuses to acceleratedly wear on a UV basis. So basically a week in the instruments, like a month in real life, so we can accelerate it considerably. And using abrasion and washability testers that remove any sort of bias that we can have on it. So from a formulary standpoint, we're building our formulations with a baseline in mind. So we might have an instance testing resins 1-to-1. So we have a quartz coating where we've got it loaded in the formulation at a specific loading level. And then we have a new, incumbent resin that's coming in saying, I have graphene oxide, so does it actually perform better? And we're putting it through these battery of tests of like, is it slicker? AKA, does it have a lower coefficient of friction? Is it actually more hydrophobic? i.e., does it have a higher contact angle? When you put through the scrub tester, they're getting the same amount of pressure, the same application, the same stuff dripped on it like Dawn dish soap to remove it. And we're putting it back on the optical tensiometer in tandem to measure at 0 washes, what's the contact angle? At 100 washes, what's the contact angle? And then we're relating those washes to how many real life washes that would equivalent out to. So for instance, we might do 10 ASTM washes equals 1 real world car wash. So when we're going 50 or 5,000 ASTM washes, we're relating that to 50 car washes. And we're saying it survived that. That's a year if you washed every week, or in the case of like biweekly 26. And then we're throwing it in the instrument to see if it yellows, cracks, peels, if it delaminates, if it keeps the surface more colorful and stable behind it. We're using all those instruments to then inform us, is this actually an improved resin or not? Things like the pencil hardness as well for measuring coating film thickness, or even things as rudimentary as dripping the resins natively onto glass substrates and watching how long they take to cure and how clear they are, how smooth they are, how fast it happens. Pairing all of that with sending it out to a very high variety of testers in different climates and different skill levels, and marrying the qualitative and the quantitative together to help build an argument for whether something is truly better, and then to inform our claims, to inform our customers, to inform you, the end user. So in the case of something like a 7-year coating versus a 5, if I was the consumer, I would view that more as a durability rating more than a literal, it's going to last 7 years guaranteed.
Exactly.
Because the reality is that's in ideal conditions. Nothing else changes. Your car is a garage queen and it never sees outside.
Almost a lab environment. Yeah.
Yeah, exactly. So it's like, to me, when our customers are going to market and you see a 5-year coating and a 7-year, think of them as durability like ratings, right? You're like, I would expect the 5-year to not last as long as the 7 under the same conditions.
There you go. Wow, that's super interesting. So we again bring an analogy to make it as simple as possible. Basically, durability claims, as far as years go or months or whatever, they're not just pulled out of your butt. Sorry for the expression,
Sure.
but there's actual. It's basically accelerated scientific tests to measure data, and based on that data, you're able to come up with a number that relates to more a durability claim, and like you said, probably more of a look at it as a rating system than actual number of months, because obviously somebody who has his car garage kept, does low mileage and maintains it frequently in California in nice weather, compared to somebody who'd have a car like here in Montreal, Canada, with our crazy winters and salts on the road and all that kind of stuff, and who uses their car every day as a daily driver and is in the elements all the time and not garage kept. You cannot expect the same amount of durability in years than you would with the guy that's in California, right?
Yep.
So look at it as I like that, a durability, more from a standpoint of look at it as a rating. So guys, I think, and I convey that in my videos as often as I can as well, this is always based on your conditions. So if people say, let's say you have a product that's supposed to last 12 months. Well, if you get 9 months out of it and you do have a harsh climate, well, that product did pretty well. It didn't fail by any means. It's just that the company that used it with their science methods, and they do have to come up with some form of data. Well, the 12 months was, of course, in ideal or optimal conditions, right?
Not
And
even
this
that
leads me
sometimes.
to, sorry?
Sometimes something like a 12-month coating is actually because we got 18 months theoretically, and we're supposing maybe only 9 months practically. So it comes up at like a 12. It's almost like an average. It's
Yes,
not
exactly.
necessarily optimal.
And for graphene coatings, another question that often comes up is with traditional ceramic coatings, maintenance every 2 to 3 months is key. In my understanding from, let's say, a chemistry perspective, is that the resin that has the SiO2 particles inside there eventually fades over time, and you need to replenish that. I don't know if that's accurate enough. So people understand in simple terms. So you need to replenish that to make sure you get the maximum performance, durability, and to maintain the properties of the coating. So you're going to have to add some sort of a topper or a maintenance product to it every 2 to 3 months. Is that, first of all, is that accurate? Is that the reason why we're using toppers on SiO2 based coatings? And do we need to do any form of maintenance on these new graphene based coatings? A lot of people seem to say, well, the brands, no, nothing is really necessary. But if you are to do something, use the same stuff you'd use on traditional coatings. So on one part, how does it work for SiO2 coatings? Do they need maintenance, and why? And for graphene, do they need maintenance, and why? What's your take on that?
So it comes back to those same hydride groups, right? So if they're capable of interacting with the water drop, they're capable of interacting with the magnesium chloride and the stuff that they're cleaning the roads. They're capable of reacting with all kinds of environmental contaminants. So you have to decontaminate that surface to basically break that bond with those hydride groups. And the reason why you're throwing like an SiO2 type product over the top is to basically cover up those hydride groups with something that doesn't have them. So then you're basically trying to get something in between the environment and the coating to try and help kind of bolster the whole system. And
there you go. So would it make sense when people say, listen, my car has been through the winter, I had an expensive pro ceramic coating done, and then I wash it and it doesn't bead and it doesn't sheet anymore, it's just flat. But then I tell them, use the decon steps, use your iron remover, use a stronger soap that's made for that. And then whoop, the properties come back. So it's because you released all that contamination that was embedded into your into your ceramic coating. It's not because the coating failed itself. It's still there. It's just that you were masking the properties, right?
Absolutely. And so there's a lot of science that goes into the cleaner and degreaser side of things to use more and more novel surfactants to remove those hard to remove road films and salts and stuff that do get built into the coating and give you that revitalized thing. But it's also at the same time, you don't want to do such a good decontamination that you start attacking the coating as well.
Yeah.
So that's kind of like the balance that has to be met to decontaminate but not strip.
And is it the same for graphene? Do they need maintenance or not? Like, how would you characterize graphene-based coatings?
Yep. So since you still have those same siloxanes at play acting as the mortar in the situation, they're still prone to the same sort of problems. I would say the graphene part of it is more maintenance friendly in terms of it's not going to have those hydride groups. So you're not going to see it bond as tenaciously or as frequently. And it might actually shed certain contaminants that a traditional ceramic coating might not. And it's kind of the same thing you see in some of these videos is sometimes we watch a coating fail. And the reality is I know what's in that degreaser that's probably actually reacting with the coating to bond to it and creating a surfactant film that's flattening the water. And everyone's like, well, that coating's out of the running. I'm like, it's actually probably still there.
So it created some sort of a residue on top of the coating that's masking its properties, right?
Yep. And then people take
Yeah.
a wet rag and they're like, see, it doesn't come off. I'm like, the wet rag's not going to cut it.
Exactly. That's why in the tests that I like to do, I always like in between chemicals that I use, reset the surface to make sure you're removing any residue with another type of chemical, like a soap that's a bit stronger, maybe to make sure you're not leaving anything behind that'll mask the property. So if you are to do chemical resistance tests, at least try to do them a bit better than just using a wet rag, because there still might be chemicals behind there that are masking the properties, and it's not because the coating is dead, right?
Yeah, so I think certain degreasers are made with more novel surfactants that have more powerful emulsification and stuff like that. And so it seems like they clean and strip better, but the reality is they're just better at wetting. So
Exactly.
when you get on the surface, they're flattening the water, and everyone's like, and we have a winner. And I'm like, reality is, give it a month, and I bet you both of those panels pop back. And the coating's not actually gone, because on a molecular level, you're going to have a hell of a time without physical abrasion stripping that coating, because it's molecularly bonded and it's protected at the reactive sites where it bonded from getting a degreaser to strip it off.
So coming from a chemical background, would you have any maybe maintenance tips for people who have either graphene-based coatings or SiO2 coatings? What would be a good way to take care of them, to maintain the properties, remove that traffic film? Any specifics that you would know or recommend?
I'm sure, us and others are going to be showing up with lots of different formulations that are going to be more tailored directly to this situation. So obviously, like I said, we can build the graphene oxide resins into water-based systems. So the idea will be, you're going to have a shampoo with a graphene oxide in it, and you're going to have a detail spray with a graphene oxide in it. And you'll kind of slowly shift those SiO2 products away. But the reality is since it's still got SiO2 in it, the SiO2 products are still perfectly valid on these graphene coatings as well. So it's not like a complete changing of the guard, so to speak.
So you can basically use silica spray sealants, the same you used with your ceramic coatings. You can still use those on top of graphene coatings because the chemistry is compatible.
Yep. So it's kind of like you're getting the best of both worlds, where there's so much tenure and development that's went into the SiO2 products. If you like them, keep using them. They're really good. And again,
so you don't have to throw your stuff away. You can continue using them as well. Okay, that's good. And so in a nutshell, let's say I come into your room. I'm just a manager at B&B Blending, but I have no chemistry background. And I ask you bluntly, listen, in a couple of words, just give me the big keywords or the big punches of what is graphene. No, not what is graphene, because we know what it is now, but basically, what are the advantages? Why would somebody want to put a graphene coating onto their vehicle? Tell me why in a few words. What are the key advantages? What is so novel about graphene that people would want that on their vehicle?
So what we saw was a much lower sliding angle paired with an equally, or if not higher, contact angle. So that means as I've described it, a dynamic hydrophobicity rather than a static hydrophobicity. Same thing as when you're tilting the panel, and sometimes those drops just stay in place. They might be a very high contact angle, but they're interacting with those hydride groups and they might stay put. So this surface, people have described it as more hydrophobic. And the reality is it's because there's less of a tilt required to get the water moving. And so the water
it's going to sheet a lot faster.
It pools into each other quicker, and then it all sheets off much, much more nicely. Additionally, these coatings do, although the pencil hardness test has already been maxed out a long time ago, these coatings are harder. You would have to drip the native coatings themselves onto surfaces to test it yourself, because obviously on a clear coat, it's different. But higher hardness, higher chemical resistivity. It's just essentially a coating plus, right? It was exactly what we attempted to do, which was try and take all of the deleterious effects of a ceramic coating, remove that, and then try and accentuate all the other characteristics more. And that's why, to me, calling it something like a graphene ceramic coating was how I pitched it to my team, because I'm like, we're trying to evolve something that's already familiar and already still the basis of what we're working with.
Okay, that makes total sense. And as far as compatibility goes, there's been a few spray forms of graphene coatings that are said to be compatible on existing waxes, on existing paint sealants. You don't have to fully strip the paintwork to get to virgin clear coat, which is there's a lot of advantages for people who don't have the time or knowledge to go through the full stripping process and machine polishing to get to bare clear coat. Is it the same thing with the products that you formulate? Are there some out there that are compatible over existing waxes, paint sealants, or existing ceramic coatings? Or do you always recommend to fully strip the paint and start from fresh to get the entire maximum performance and durability? Is that more with the traditional ones in the glass bottles that you'd apply with a foam applicator block and a micro suede on kind of like a traditional ceramic coating? So do those have to be applied on virgin clear coat, and the spray forms are okay to use on existing protection? How would you say that with the stuff that you're producing?
I mean, more broadly speaking, it all comes down to how effective do you want the product to be, right? So if you're going to kind of half-ass it, you're going to almost kind of get half-ass results. And that's okay. Not everyone wants to have it be absolutely perfect, but in order to get the proper performance, you're going to have to do the grunt work to get the surface prepared for it. That's just how chemistry is. It doesn't care about your time. It cares about what's capable of reacting.
So it's a good thing when I tell my viewers that the more time you spend prepping your paint, the better performance you're going to get out of the product, and obviously the longer durability. If you want to get those maximum claims, you have to put the effort in. And I mean, you do that at the beginning, it's once, and then it's just maintaining that.
Yep,
exactly. So for a few hours more that you're going to spend on initial application, you're going to get all of the benefits. Why not do it, right?
Yep, exactly. And so for me, whenever I'm providing protection to my vehicle, I always add a minimum clay. That's just like basically step one, no matter what, is getting anything stripped off. And there's countless videos and pictures out there showing what the clay pulls off of your vehicle. And it's because it's that effective, and it's really not a difficult step. So I would always encourage people to at minimum clay.
And graphene coatings, because I know ceramic coatings, one of the chemical decontaminants when we use iron removers, that's actually a recommended step to not only remove that oxidation off the surface, but it's actually a step that they can resist to. So is it the same with graphene-based coatings? If you use an iron remover every 6 months, let's say, to remove the iron particles that are embedded and started to rust, is it fine to use with graphene coatings too?
Yeah, those things complex with iron, and iron is not carbon, obviously.
There you go. Perfect. By the way, am I maybe the first channel to get an interview with you? Is that a first?
Yeah, I think so. I mean, I've done some behind the process things with Joe and stuff like that on the Adams polish and stuff, but you know, we've largely been kind of reticent to interact with influencers because we are supposed to be this invisible hand of the industry. Yeah. But I just felt compelled in this situation to come out and try and explain what is actually going on behind the scenes in the industry and dispel some of the myths, because they just kind of, it's almost like a rumor mill. It's like, if you don't address it, it just kind of gets worse, and people
exactly
more tinfoil hatty about it. And the reality is, it's like, there's nothing sinister we're doing, and there's nothing different about the car care industry than there is about cosmetics industry or home care industry or any of these other industries. It's like you said earlier on the video, not everyone's going to have the time, money, or even interest to have a fully vertical integrated company. And that's okay.
And I'm sure my viewers really appreciated this talk. I mean, and that was one of the key points. We wanted to debunk some myths, which I'm sure we did. Hopefully now people understand that this is an actual technology. They understand the reasons why, the naming process, the marketing behind the labels, but now actually what's inside the bottles as well. And they understand that there are actual benefits. And I'm looking forward to the future of this. This is the real thing. It really exists. And there are actual chemists behind, including yourself, that are shaping the future of the car care industry, and surface protection is one big one, because everybody wants to protect their car now. And I think through the many YouTube channels that we see in the detailing world, I think one of our goals is to empower people with knowledge, information, to get them out there, enjoy detailing their vehicles. And when you do have that knowledge and understanding of what you're doing and why you're doing it, I think you're more prone to enjoy the process and essentially to make better purchasing decisions. So now hopefully people understand that graphene-based coatings, and don't freak out, guys. Is it graphene oxide? Is it graphene? Don't get into how much percentage is in there, MSDS sheets, and let's not go through that. Hopefully this video made you understand why. And it's through discussions and productive talks like this, I think, that is important to have out there. And thank you for taking the time. I don't know if there's any closing words that you'd like to say or add.
Yeah, definitely. I mean, thank you for having me on here. It's obviously a really cool moment for myself to be able to speak to you as a fan and be in front of such a large audience. Obviously, we get forgotten about a lot in the lab and we're just back there working away. So it's really kind of a blessing of mine to be able to interact with the populace and the community. But, you know, hats off to all the other formulators out there as well and the other chemists. I know what kind of pressure they're under from their management teams and their bosses, and it's a highly competitive atmosphere. And I don't know, I think it's a lot of fun. It really pushes innovation because everyone has to perform, and I think everyone's doing an excellent job. So shout out to all the other chemists.
Yeah, that's a good point. I think that's one thing I want to say too, to if there are any managers in those labs watching these videos, let your employees come up with a creative process, give them that freedom. Don't put too much pressure on them because they're shaping the future of this industry, which I absolutely love. Been detailing cars for over 23 years now, and still to this day, I'm super passionate about. Hopefully I convey this through my videos. You can still see the smile. I'm like a kid in a candy shop. I love geeking out with stuff like this. I never had the opportunity before to talk to the people behind the scenes. So although you were using some products, I mean, for me, it's such a gift and a blessing to be able to talk to people like you behind the scenes and get to understand the technology and all the cool things that are coming in the car care world. So thank you again, Chris, Chief Technical Officer at B&B Blending. Hopefully we'll have more talks like this in the future. Thanks for taking the time out of your busy schedule as well to do this. And so, yeah, guys, I hope you appreciated this as much as I did. And yeah, Chris, shout out to you and all your team, and we'll talk again soon.
Thank you so much. Appreciate your time.
My pleasure. Have a good one.
You too.
That was an awesome talk, guys. I hope you enjoyed this. Again, thanks to Chris from B&B Blending to lending himself to this interview. A bunch of questions that I had and that you guys had as well. Many of them, well, all of them, I think, were answered. If there are any more subjects or topics that you'd want me to reach out to and discuss with these chemists, because I know you guys love these types of videos, drop a comment in the comment section under the video. Let me know what future topics you'd want us to talk about, what myths you'd want us to debunk, or just what's the future, maybe technology that's coming up in the car care industry and the car detailing products world. It was very, very exciting. I love learning new things. I think when we do learn new stuff, you get empowered to go out there and enjoy detailing your car with way more knowledge and understanding of why you do the steps, why you use a different type of product or a tool to perform those actions and steps, and basically just come out with better results in the end. If you want to continue to learn more about car detailing, guys, so all the products, equipment, tips, tricks, and techniques, and interviews like these as well, make sure that you hit the subscribe button that's found under this video, and that way you'll subscribe to my channel and never miss my future videos. Also, make sure you follow me on my Instagram page. I'll drop the link to that right here, and I'll put the link, of course, in the description as well. You never know what awesome original content I have there, including giveaways, which sometimes I do only on the Instagram page. So check me out over there. And yeah, I think it's pretty cool that we get to do this. It's because of you guys. We are one of the biggest and fastest growing detailing channels on YouTube. And at the moment of this recording, we're way over 530,000 subscribers and 60 million views. And that's all thanks to you. We get to have access behind the scenes to a bunch of stuff like the chemists behind the technology. So yeah, I hope you enjoyed it. And well, in the meantime, don't forget, guys, to keep it tight, keep it clean, and I'll see you on the next one.